Hey guys, welcome back to my shop. This is a pick that I did. This was a marketplace find, and this came up on Facebook quite a while ago, actually. And I forgot exactly what it started out as for a price, but I just kind of kept an eye on it. Saw the price dropping. Guy kept dropping the price, and got down around $50, and I just kept watching it. And then finally, I messaged the guy and I said, I've been thinking about getting a transistor tester, and I know that from what he had said in the listing, that other than he could get it to power on, he doesn't know anything about it. And I could tell that, it had been in an area where there was moisture. So I said, I'd be willing to take a chance on it if you want to take $25 for it. And what ended up happening was, instead of telling me to go pound sand right off the bat, he actually came back and he said, let me just see what happens, give it a little bit more time. And he said, I'll tell you what, if I still have it in a week, I'll take your 25. And then a week later, I think he messaged me or I messaged him, I forget which. And he said, yeah, if you still want it for 25, it's yours. So I ended up buying this piece, and then there was another piece he was advertising that he had to drop the price way down and still didn't get any takers. I got him to practically throw that in for nothing. We'll get to that a bit later. And then there was something that he hadn't even gotten around to advertising yet. He's kind of a junk collector, picker, guys that do cleanouts and that bring him stuff all the time, I guess, and he tries to turn it for a buck. So I'll show you that beast also later on. But for right now, let's concentrate on this here. This is a Hickok Model 220 transistor tester. As transistor testers go, this was actually a pretty decent model. Back in the day, there are a few particular models of transistor checkers that come up on different forums as being mentioned as worthy of adding to a vintage electronic test bench, and this is one of them. I, at one point, had probably one of my favorite transistor testers back in the day was a B&K model. I forgot exactly what the name of that model was, but that had a kind of a neat feature where you didn't have to know the pinning of the transistor at all. You literally just you hooked up the three leads, test leads to the three leads on the transistor, and it had a lever that you could rotate through a whole bunch of positions. You could move it up and down through a bunch of positions, and when it found the correct pinning and on a good transistor, it would just immediately start to sound an audible, strange little beeping noise that almost like singing a little beeping song that basically told you you had the correct transistor configuration. And then you could turn the knob over to the leakage test and read the leakage current on the transistor immediately. It was a nice, quick, easy to use transistor tester. And they also had another version of that which was even more advanced, and I believe that is a B&K model. You have to bear with me. I actually kept that saved in case at some point one of them pops up for sale. I wanted to I think it was a B&K 530. So there's a model B&K 530, which is a deluxe version of the one that I had years ago. I also had a Sencor, I think it was called I don't remember the model number on that one, but it was called the Super Cricket, which was also a nice transistor tester. It was an impressive looking transistor tester because it was about as wide as this, only maybe a little bit taller, and it had a huge analog meter for gain and current leakage current. So that made it kind of really look really cool, and it was expensive as heck back in the day because all Sencor stuff was kind of pricey. But anyways, so I ended up getting this thing. If I can get this thing to work, or if it does work, I know it doesn't work. There's an issue right off the bat with this switch right here. This switch is responsible for switching between modes, transistor testing or diode testing, and it's just completely broken. So what I'm hoping maybe that's the only thing that's wrong with it. So it's got a little bit of light corrosion on it here. It's got a little door that opens up in the top, so we've got a little place for our meter, our test leads to be stored when it's not in use. Here's what it looks like on the back. The cord is actually in surprisingly, it's filthy, but it's in surprisingly good shape. The insulation's not all dry rotted, cracking off. The ground prong has not been cut off by some complete hack. So, anyways, so I figured what we'd do is we'd open it up so we could take a peek inside and see what the overall condition of the electronics inside look like. And also, see if we can't maybe just hot wire that switch temporarily to, because I don't think I have a little tiny toggle switch of that style. I might, I'll have to check. So for starters, we're going to figure out how to get into this bad boy. Well, I guess I'm going to start with these screws on the back here that hold these two plastic pieces on and see if maybe the whole thing slides out of this. Alright, so it appears that underneath these covers are these screws here. Oh, that's nice. That looks actually nice and clean in there. Looked like that little IC chip was kind of up a little bit, so I'm just reseating it. It actually looks like it's in great shape on the inside. Even under magnification, I do not see signs of corrosion, which I was worried about. Looks like this transistor's been replaced at some point, evident by the fact that whoever replaced it didn't clean the flux off the board after they finished, whereas these look clean. Yeah, so that's a stinker. So that toggle switch is actually mounted, looks like it's mounted to a PC board up here in the front. It's buried right in here. See it? Aha! That's how you get to the screws that are inside here that are holding this part to the rest of the case. Just take these little side things and they slide out. If I take these 4 screws off right here, that'll take this completely off, but that doesn't really do anything for me. Not only that, but the transformer is riveted. The power transformer right here is riveted to the back of the case. And that just pulls off, okay. So how do I get that front? I think I'm going to take these front pieces off. Alright, so now I see if I take these 2 screws and these 2 screws off, this whole front face plate might move off. But, let's see. It doesn't really solve my problem getting to that board. However, the board appears to be held to the front by maybe these screws. I'm just going to take these 3 screws loose. Might be onto something there. And now, around this broken toggle switch, there is a small nut. So I think if I unscrew that and these 3 screws, I might be able to drop this whole board out through the back. Yeah, there we go. All right. Now, will it fit through here and all the wires long enough? Okay, so now I'm going to take these screws that thread into this rail. No, better yet. I think instead I'm going to take the 4 screws off the front and let this whole front drop forward far enough so I can get that board out. There we go. Not sure what's holding it on that other side. No, nothing really. Okay. All right. And that gets this board out where I wanted to see it and exposes this switch. All right, so there's a part number on the switch. MPC 223 USA. Kind of doubt we'll find one of those. Well, guys, I have been able to get this switch out, but not without doing a little damage. I really hate two-sided boards that have traces on both the top and the bottom side. They pose a problem for me. I do not have good desoldering equipment like I wish I had, like a nice Hickok desoldering gun. So I have to get by with solder wick and my regular iron, which normally for a one-sided board I can do just fine. The problem with a two-sided board is, and especially with a component like a switch like this, where these pins really act kind of like a heat sink and draw that heat up. You got to get a lot of heat to get that solder to flow out from one side. And the problem is, you know, the switch was in here like this. Underneath the switch on this top side of the board, we've got these runs, these traces right here that are just tiny. And of course, I lifted a couple. So they actually, you know, you think you got it desoldered and you wiggle it out and lo and behold, you see, oh, you missed a little bit of solder there, and the little circle of the trace comes out with the pin. That's a shame. Oh, so I thought it would be so hard to get this switch, and I don't think it's going to be. This is an MPC-223. I already figured out the manufacturer, which apparently the manufacturer must have been a division of Cutler Hamer, the big electrical company that you know, makes circuit breakers and boxes and everything like that. So I'm going to get to all that in a moment, but right now I'm going to zoom in and show you the carnage on the board here. So there we go. So you can actually see there's a tiny trace that went from this pin and actually went right over to this pin. So that'll be a piece of cake, because I can add a jumper wire on the back side of the board to actually make up for this trace. Trace is actually still there, but this half of it, this part right here that goes around the leg. The problem is I gotta solder this back in, and I'm not going to be able to see whether or not solder is flowing and catching what's left of this trace. So I'm actually at this point going to be better off actually removing that trace entirely and subbing a piece of wire on the back side. I also took out this part that goes to the pin here. So this little trace goes over, and I can't quite see what that goes to, but I'll have to identify what that goes to. That actually looks like it goes to might go to a feed through to the other side of the board. There was nothing on this pin because this pin is attached only on the back side to a trace. We've got this one is still intact, so that's what it's supposed to look like. This one is also missing now, the ring, but that trace comes right over to this little drop capacitor right here. So again, I think from the other side I can add a jumper wire. So I can make this work. And I think what I'm going to do now is I'm just going to identify a good replacement switch to fit in there, get that ordered. Originally I was thinking, well, I just jump out what I have to jump out to make it work in the transistor mode only. But now that I determined the switch is pretty easy to get, I think, and not that expensive, I think I'm just going to go ahead and get a new switch. Oh, hold the phone. Think I'm going to change my mind, and I am going to hotwire this thing because I want to make sure this thing works before I shell out the money for this switch. So I was able to cross the switch to a electroswitch part number, an A223S1YCQ. Cheapest price I was able to find was at Allied Electronics for $7.90. Cheaper than Mouser and cheaper than Newark and cheaper than DigiKey. However, even though it was cheaper, you still got to deal with the ridiculous amount of shipping that they charge on these little tiny parts, even though they could just mail the thing, which is probably what they end up doing. So you think, well, maybe I'll turn to eBay and find a deal there. Nope, not so fast. Here's the switch on eBay. It's $13.64 and then $9.90 shipping. So, you know, I'm going to be into this thing for like I'm going to be into this thing for the switch is going to cost me close to what I paid for the whole thing. That I don't even know if it works, right? So that's kind of crazy. Oh, by the way, you might be asking, well, hey, why don't you see if you could find the original switch? Well, the original switch is a JB something company. And, oh, I did find somebody who has them on eBay. Look at this guy here. He's got some. He only wants $400 for them because it's a lot of 47. Oh, I already did the math. It's actually, even if you buy all 400 from this guy, that's not that great of a deal, you know? So, and clearly these, looking at the box, these are old surplus switches he's got, which doesn't mean there's anything wrong with them, but, I mean, come on. $400, he's going to have those for a while. So in order for me to put in the correct jumpers on this PC board so that I can actually simulate having the switch in there in the transistor position, I first have to fully understand exactly how the switch works. Now, for those of you who aren't familiar with these types of switches, this is what is referred to as a double pole, double throw switch. And essentially what it is, the double pole part means that it's almost like there's two switches in one. When you're flipping this lever, you're actually actuating two separate sections of the switch that are actually delineated right down the middle by this line. So we actually have a switch on this side and a switch on this side. So each separate switch has three connections. So if we just cover up one side of this, that would be what would be called a single pole double throw. So sometimes you'll see switches will be notated as SPDT or DPDT, double pole, double throw, so on and so on. So getting back to our switch, we've got two separate poles, two separate switches, and then each separate switch has a double throw feature, meaning that it's not just an open or closed switch, which would have two pins. We have three pins because this switch is capable of doing either connecting the center pin to this pin or the center pin to this pin, or if it's in the off position, like many of these switches have an off position in the center, none of these pins are connected to each other. This is a little bit unique because instead of having on to one side, off in the middle, and the other on position to the other side, this has just on. It actually says so right there, on. And what that means is that there's no center. I can't flip this switch because it's broken. But if I could flip this switch, it would only click back and forth. So it would either be in the position where these two pins are shorted to each other, or the other position, these two pins are shorted to each other. There's no middle position which would be off. So now that we know that when I flip this switch in one direction, that two of these pins short together, and then the other switch is doing the same thing. Now that I know that, I can start to think about what I've got to do here for wiring. So The other thing you're going to know is you're going to know how this switch actually works internally. So mechanically what's happening is there's a little piece that pivots over. So when you put this switch in this position, you move the switch lever that way, it actually is going to cause the contacts to close on the opposite side that way. So in other words, with the switch in that direction, right now we're actually shorting center pin to this pin, and then over here on this side, center pin to this pin. There's never an electrical connection between this pin and this pin, this pin and this pin, or any. In other words, think of that line in the middle there as a line of demarcation. Think of it as a wall that's keeping these completely electrically isolated. That's how it's supposed to be working. All right? That way you can have a single switch that's actually, when it's actuated, can alter more than one circuit. All right? So now that we know that when the switch is in that direction, these two pins are what are connected. Now we can look at the actual board and figure out which way they want this switch, this toggle switch, pushed in order to make it work for transistor. So if I look at the front, I've actually got this upside down. I can see that it says XSTR on the top and diode on the bottom. So that means when this switch is in the up position, when this is flipped up, that's when it's in the transistor position, which ironically would actually be shorting the center pin to the lower pin. If I was looking at this as this being the upper pin and this being the lower pin, it's the center pin to the lower pin, because remember, the switch is up and it's opposite. So center pin to lower pin. So then I look at my board and I say, oh, well, hold on now. Let's see. The board goes in this way. So if I want center pin to the lower pin, again, we've got this upside down, so this is the lower side. So now I know that I want this connection here in the middle to be connected to this lower pin. And the same thing on this side. So all I've got to do is simulate that, and Bob's your uncle. All right, I believe I have successfully managed to jumper out the traces on the board to simulate the switch in the transistor position. So let's see. So when I first got this unit from the gentleman, what I noticed was that when I would wiggle this switch, these lights would flicker on and off. So now, of course, that the switch is completely removed out of circuit, hopefully this is going to behave the way it's supposed to. Well, guys, I was able to get this transistor tester operational after all. I had a bad connection I had to resolve, and I also think that cleaning the switch is also correct part of the problem. One of the other things I discovered in the process is that the fact that this switch right here is a 2-position switch, and this switch is a 3-position switch. For some reason, I thought maybe this had 3 positions because of the way that it's labeled, but I now realize that it's actually a 2-position switch. So this transistor tester has 3 basic modes that can be selected, and the top mode, the good-bad test, actually has a built-in feature that allows you to randomly hook up the 3 leads of the tester to the 3 leads of the transistor that you want to test, and that the device will automatically determine the correct pinning of the device and the sex of the device, whether it is a PNP or NPN device, N-channel or P-channel device. So with transistors, we say PNP or NPN. With MOSFETs, often it's N channel or P channel. But we're getting all hung up on that. So I could order a new switch and make this 100%, but I decided that I'll probably not even just bother. I'll probably just leave it wired for transistors only, because I rarely need to check diodes for leakage. I can do that with my my multimeter. My experience is diodes tend to not get leaky; they tend to just short. So short open test on my multimeter for most diodes is sufficient. But just going to demonstrate how this works. So right now you can see that the lights, the LEDs, two of them are flashing. The bad is flashing and the NPN is flashing, and that's because no device is hooked up. That's normal. So what I'm going to do now is I'm going to just randomly hook up the leads to this transistor. This is an NPN transistor that I happen to just pull out of a junk TV chassis or something I had laying around here. And we'll notice that what it's doing now is it has stopped doing that rapid flashing, and it is doing a more slow cadence as far as the whatever it's doing. And what it's doing is it goes through and it tries all the different configurations of the wires, and it sees which of those combinations of wires of connections will actually create a good test. So if no combination, it's literally internally it's switching these connections right here from BCE to BEC to CBE to CEB to ECB to EBC. I think I covered them all, right? You get the gist though. It's running through all of them. And it's running through them and checking in both and assuming it's either an NPN or PNP. So it's trying either. And then eventually it finds one of the combinations of wiring pinouts and one of the combinations of the two possible polarities that will create a good reading, and it will pause on that. So that's why every once in a while you'll see it'll flicker again, but it keeps coming back to, notice it comes back to and it pauses on lighting the NPN or the N-channel device light and pausing on that. And that's its way of telling me that this is a good NPN device. This is just a go, no-go test at this point. It's not testing leakage, and it's not testing for gain or anything like that. It's a very basic test. However, if the transistor were completely shorted, we wouldn't be able to get this. And if the transistor were completely open, we wouldn't be able to get this. So this is a good indication that so far so good, right? So that's what it's telling me. It's also telling me that it has identified the control lead on this device, which the control lead on a transistor is the base. And it's telling me that, see, it says base down here. All right. It's telling me that lead 3 is the base on this device. So if we go down and we look at my connectors down here, which are just out of frame, they're labeled 1, 2, and 3. And in number 3, I have a yellow alligator clip. And I currently have the yellow alligator clip on the middle pin of this transistor. Now this transistor is a BC548. It's a pretty common NPN transistor. And if I go online and I Google a BC548, I can find plenty of information on that transistor. And we can see a pinout right here of the transistor. Looking at it.
Check out these pictures.
Yeah, I don't think I asked you to do anything. Oh, you stinker. Okay, so looking at this picture right here, it's showing me the pinout is pin 2 is the base. Okay, remember I said the base is the control. So the middle pin is the base, and that's what this is telling me. It's telling me that the pin, the middle pin that I have the yellow lead on, yellow lead is number 3, and it's telling me that number 3 is in fact the base. So it has correctly identified the base of this transistor. Now, I haven't read into the manual yet enough to see whether or not it's also identifying the collector or not, because remember this collector thing down here, it's actually lighting up number 2, saying number 2 is the collector. Right now, number 2 is the black wire. And I've got the black wire actually on the far right. So that's number 3. And the problem is that on my pinout here, according to online, number 3 is actually the emitter. So I don't think it identifies the collector. I think I have to kind of ignore that for the time being. Yeah, the manual, I found a PDF online that I downloaded, and the manual clearly states that in the good-bad test mode, that if the device is good, the 220 will light the appropriate LED indicating whether the device is P, NP, or NPN. It will also identify the control electrode, so that would be the base in this case. The reason why they don't say base is because you can also test MOSFETs or other semiconductors like SCRs, where the control electrode is the gate. Getting off track here. So again, it says it will light it, da 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 da. It will also identify the control electrode. And it says in the case of a 2-lead device, which would be a diode, that it can identify which one is the anode and cathode. But it doesn't say anything about identifying the collector. Then it says, note, in the good-bad mode of operation, the tester will cycle through approximately once every 2 to 3 seconds. The proper indication is obtained at the end of the cycle. In other words, it's letting us know, ignore the fact that it's flashing bad real quick, because that's where it's cycling through again every 2 to 3 seconds. So it's 1001, 1002, 1001, 1002. And it's pausing on there. So again, that's the good indication, that it's a good NPN transistor, and that the base is is connector 3, which in this case is going to pin 2. So far so good. So now let's figure out how to do the next test. All right, so now I'm going to get ready to test the gain of the transistor. And to test the gain of the transistor, I have to slide the switch down to the set type / base position. But the instructions are pretty clear. I can't just flip that switch down anytime I want. The switch has to be moved from the good-bad indication to the set type base position when it's actually paused on the correct setting. So I have to wait for that pause when this light is lit and this light is lit. And once I do that, the system stops cycling through and trying to see what other configurations might possibly work. It now basically has set the system to stop messing around with changing the positions of the base collector emitter on this transistor under test. It is now ready to do the gain test. So the next thing I have to do is, now that I've got that in the correct position for setting, I come over here to this polarity switch and I select NPN or PNP. I already know it's an NPN transistor, so I have to make sure this switch is in the NPN position, and it is. Then I come over here to this 0, not the ohms adjust, this meter 0, and I adjust this to 0 the meter. That looks about right there. Once I've done that, now I flip this switch down to parameter, and I then come over to the collector switch, which, remember, we have one of two positions, and I switch it in whichever of these two positions gives me the highest reading for gain. And there it is. That's my gain. Now, apparently, the way that the scale works is that actually 10 is to the right, and it actually goes up to the left. So we're actually looking at the gain over here. Now, you also have to keep mind of where the range switch is. I have it in the 0.1 position, times 0.1. If you have it in the wrong position, you can see it pegs the meter. So that's the position that I want it in. And now, at this point, the manual basically tells you that you've now tested everything you really need to know about this transistor. It almost literally says something to that effect. So that's really as far as you have to go. Now, there's other tests you can do. If the transistor is in circuit, you can test it in circuit, but the resistance of the surrounding circuitry and how it's affecting the test has to be taken into account, and that's where these other tests come in here, these ohms tests. There's also a field effect transistor position, and I don't know what this last position is for, but I'm not really concerned about that. I tried cleaning this weird stuff on the face here off, and unfortunately, no mild cleaners seem to be taking it off, and I didn't want to get too overzealous with cleaners, because I'm sure like this, I've got cleaners like acetone that will definitely clean that off, but they'll also completely remove all of the wording on the front of the unit. So I'm going to live with the way it looks. It might not be pretty, but at least it's working. All I've got left to do now is to put it back together. Well, in the words of Matthew McConaughey, all right, all right, all right. So, looks like I got a decent piece of test gear to add to my electronics test bench that I want to put together. And I'm going to keep my eye out for that B&K model that everybody raves about. But, you know, unless I could scoop a really good deal on it, I'll probably live with this for a while. All right, so I think we're going to close this out right here. And then in the next episode, we're going to take a look at the second of 3 items that I picked from this pick as far as vintage electronics go.